We now consider Saturn, our next Jovian planet after Jupiter. And of course, as we go through the solar system, we're moving further away from the sun now. This slide does not show the spacing of the planets, but it does show the approximate sizes. We're a little bit smaller than Jupiter, and Saturn is interesting for its density, the mass divided by the volume. Again, the planet's mass is calculated by observing satellites of Saturn, measuring how long it takes them to go around Saturn and what the size of their orbit is. Astronomers can calculate the mass of Saturn. We can measure the diameter of the Saturn, the angular size, and knowing how far away Saturn is from us, astronomers can calculate the diameter, the mass divided by the volume then, and well, once we have diameter, we can calculate volume, but mass divided by the volume provides the density information, and it turns out that Saturn is about 70% of the density of water, about 70%. Jupiter was a little bit more dense than water. Jupiter has more mass, and its material gets more compressed. Gravity is stronger. It pulls in the material with more force and has a higher density. Saturn does not have as much mass, so its more gas nature exhibits itself, having a density that's less than water. It still is compressed in the center, of course, but it's not compressed as much as Jupiter, so its density is a little bit smaller. Its mass is proportionally taking up a little bit more volume than the mass of Jupiter. So a little bit less dense than water. You'd have trouble floating it, of course, because you don't have a bowl of water big enough, but it is less dense than water. Another view here. We're not going to discuss the rings in this video. That'll be a later video, but today just the planet itself. One aspect would be, where would you see it in the sky in November of 2014? So if you can locate Saturn, the lower right here, and locate the Earth in the blue orbit. So we have the Earth, Sun, Saturn a little bit to the left of the sun, but it's so close on the sky. If you're here on the Earth looking, Saturn is just a little bit to the left of the sun. We know that puts it in as an evening object, but it's very difficult to view in November. It's pretty much in line with the sun. The sky does not get dark enough before Saturn sets. So you'll have to wait. It'll become visible as the Earth, of course, is going faster than Saturn. We'll have a situation where we can view Saturn in the early morning sky in a few months as the Earth moves around over to here, Sun here, Saturn to the right of the sun. We know that if an object is to the right of the sun, then it's going to be an object that can be viewed in the early morning, just before sunrise. So there's our situation with Saturn. As far as the distance to Saturn goes, you can maybe estimate off of this diagram, but about 9.6 astronomical units. About 9.6 astronomical units. And that gives it a period of orbit around the sun, a little over 29 years. 29 years. So we're, again, further away from the sun, gravity is weaker, and we get longer periods. A view of Saturn. And you'll notice right away that the clouds are not as distinct as the clouds on Jupiter. You have to use different wavelengths to view deeper in through the haze of the upper atmosphere, or different techniques of enhancing photography, image processing to bring out the cloud features, or occasionally there will be some features that come into the upper atmosphere. And we'll see those. So using different wavelengths, ultraviolet, we get a little bit more distinctive separation of cloud features. The visible, and I presume it's infrared down here. Apologies on blocking the view, so I'm going to move myself out of the way. So infrared down here. But again, astronomers have access to different wavelengths now as telescopes are orbiting the Earth outside of our atmosphere. Infrared and ultraviolet light is available to view. And we also have an advantage for Saturn. We have a very powerful satellite, well-equipped satellite. The Cassini spacecraft is in orbit around Saturn. If my memory is right, this satellite is about the size of a school bus. So it is very capable, a lot of instruments on it and giving us good information. In 2009, here's one of the upper atmospheres feature. There was a storm develop in the atmosphere of Saturn, and it's persisted a few years, I believe, that before it faded out. Another view here of a storm in the atmosphere. And there are places on Saturn where lightning has been recorded. And again, with good equipment in orbit around Saturn, we can get more detailed information. So you can see these flashes of lightning. The images were taken, and by coincidence, some of the frames have lightning visible in them. So again, evidence of storms, evidence of dynamics in the atmosphere of Saturn. Another thunderstorm down here. I think this one was called the Dragon Storm for kind of its curved nature for some of the clouds. And again, this is Saturn. It's been image processed to bring out the features. Another interesting feature occurs at the North Pole. The North Pole is here. These clouds are in motion around the North Pole. And you can just start to get a hint of something a little unusual in terms of the trajectory of the clouds. And a little here again, there's kind of a corner here and kind of a corner over here. In fact, there is a long-lived hexagon at the North Pole of Saturn, a hexagon shape. And it was observed around 1980. So it's, again, like almost 25 years of observation. More than that now. So 30 years of observing it. Here's a little, again, frame by frame stitched together into a movie showing the rotation of the clouds around the North Pole. And again, this distinctive hexagon feature. This has been reproduced in a laboratory where scientists put together a combination of a cylinder of water and then made a jet stream and blow around here, and they were able to reproduce approximately a hexagon as well. So evidently something to do with the jet streams in the atmosphere of Saturn gives rise to this particular shape. It is not made by the Saturn resonance. It's an atmospheric feature that's naturally occurring with the laws of physics in the atmosphere dealing with jet streams. A little bit more wide view of the hexagon out here and down in through the northern latitudes of Saturn. The South Pole has been photographed as well by the Cassini spacecraft, and look at these storm clouds, evidence of convection of clouds rising and falling, and again the swirling nature for the cloud material. Southern Lights, aurora. So what does this tell you about Saturn? The fact that we're seeing aurora at the southern pole tells you that Saturn has a magnetic field that guides particles from the sun into the polar region. And again, when these solar electrons reach here, we get a situation where the atoms in the atmosphere are energized, and we have a aurora, southern lights, and a little bit more enhanced. And again, the aurora oval here, and again, magnetic field of Saturn, not as large as Jupiter, but still much larger than the Earth's magnetic field, and guiding particles into the atmosphere. What's that tell you about the interior of Saturn? Saturn has a magnetic field giving rise to aurora in the polar region. Now, again, the dynamo theory is the hypothesis, and we have liquid metallic hydrogen inside the core of Saturn. Saturn is also similar to Jupiter in that it emits more radiation than it receives, radiation being light, energy. And again, our hypothesis would be gravitational energy is being released as things move towards the core of Saturn. Possibly also remnant energy, and possibly also radioactive isotopes, but the gravity has the best capability for producing this extra energy that's emitted. So there's our quick tour of Saturn, another gas giant planet. Atmosphere not quite as colorful, have to do a little bit more work to see details in the atmosphere, but there are storms, there are aurora, and overall another very interesting planet, and again being well investigated as the Cassini spacecraft is returning to us measurements not just of Saturn but also of the moons of Saturn, and that will be a subject for a future lecture as well, lecture discussion, illustration with the characteristics of the moons being discussed in the future. Might point out also, just one last comment here, these clouds, the features that can be identified, there's a different period of rotation at different latitudes. And again, we're in the realm of the short rotation here of a kind of similar to the effect that Jupiter had with, and I forget the time for how long it takes Saturn to rotate. My memory is something on the order of 10 hours. That's going to be wrong, but 10.6 hours. So I guess not too far wrong. So I think that's where we better end here and let you do reading on your own and ask some questions. And I still have a little uncertainty here about the rotation period of Saturn, so don't quote that to anybody else, but on the order of Jupiter's rotation as well. But the point is faster rotation than the Earth. Again, we've got a big object rotating, so keep reading.